Thank you. My name is Chris Price. I'm going to be talking to you today about creating D3 components. Let's start as the last one started. Who's used D3 before? Awesome. And who can teach me stuff about D3? Alright, we'll find out. Okay, so I suppose as opposed to Paul's talk as well, mine will get a bit techy, so there will be code. Hopefully that's a good thing. We'll see. So I'm going to talk about D3, the fundamental concept in D3, as I believe it, which is data join. I'm going to talk about how you create components in D3, which kind of becomes a problem as you build bigger things with D3. And I'm going to talk a little bit about kind of where we picked up this experience of building with D3. So, first off, the basics. What is D3? So D3 is kind of a bit of an old school library. It's got quite a bit in it. So what kind of old school library wouldn't be complete without some kind of DOM abstraction? So first up we got selection. So D3 I can select by ID. I can select by basically any CSS selector. I kid you. Individual selections, multi-selections. I can manipulate the DOM. So once we've got the elements, set text on it, attributes, styles, the lot. This should all seem very familiar, hopefully. I've got events as well, so I can add click event handlers. An interesting thing in D3, might catch you out later, you're only allowed one event handler of a certain type on a certain element. That's what the namespacing is about. That sounds weird, sounds like a restriction, but I'll come back to why kind of trying to do things in an idempotent way in D3 is good, because you want to do that. That's really powerful, but watch out, it could catch you out. We've also got, obviously, an XHR abstraction, which is fetch didn't exist back then. So get me some JSON from the URL. We've got animation. I would say I'm not an expert on the animation in D3. That's not going to be the focus of this talk, but you can do it. So using my animation skills, I'm animating from a blue background to a red background. Linear duration, jQuery, you probably recognise that. This is where kind of D3 becomes slightly different. So D3 tries to split things up. It doesn't want to build everything kind of on top of each other. It's trying to give you the separate building blocks that you can combine to make a chart. So one of those building blocks, the fundamental part of the chart, is a scale. So a scale is something that takes a domain value. So if you were plotting temperature, I don't know, somewhere between 0 and 100 degrees, and it will convert that into a pixel coordinate. So you're rendering on 640 pixels, so somewhere between 0 and 640. So the most simple scale is a linear scale. So there you can see in this example, I've chosen to go from -10 to 10. As my domain. So that's what my data will be valued between -10 and 10. And then on screen I'm rendering up to 500 pixels. So if I give it -5, I'm going to guess the maths right, I'm not going to check it, I'll get 125 out. Not only can I go one way, so not only can I use that to go to the screen, but I could also use that to go to the other way. So if someone's interacting with the chart, I need to be able to get back from the screen coordinate to the kind of underlying data value. That's quite simple. It's a linear scale. It's not really doing very much. I'm sure you could code that up yourselves. But it also hides away some of the other algorithmic complexity of building a chart. So one of those things is if you're trying to do tick positioning, so that is trying to position the ticks on an axis on a chart. If anyone's ever tried that before, that's incredibly hard. It's also kind of a circular problem, because as soon as you position them, you come up with values, those values have a label associated with them, the labels could then collide, and then you've got to go around again. So D3 kind of hides quite a lot of that for you. But this scale kind of has no visual representation, it's purely an algorithmic component. As well as simple things like scales, you've got specialised layouts, so layouts like a sunburst type affair or a pie chart. So this is kind of the most simple. You give it data and out pops the kind of the stuff you would need in order to render a pie chart. You've also got geometric primitives. This is an area I know not very much about, so it looks like this. Won't say much more. You also got geographic projections. I know less about geographic projections, but isn't it cool that you can use lambda and other Greek characters in there? So I said scales don't have any kind of render to them. They've got an axis. So if you want to render an axis, you need something else to help you out. D3 gives you those kind of building blocks. So if you've got a scale, you want to render it, use an axis. So an axis, so there's our scale again. We basically pass it in to the axis. And the axis is an SVG representation of that scale. So when you give it and you give it a selection and then you invoke it in that selection, then it will render an SVG axis there using the scale to provide all the kind of algorithmic side of it. So for example, should you want to make a canvas implementation of that, you could reuse the scale and all the hard work's being done. It's just the drawing operations you need to perform yourself. You've also got other helpers. So it's, as I say, it was predominantly D3. It was an SVG library, but it can work with kind of any DOM or different bits can be used universally. But with SVG, a common thing you want to do is generate paths or path data strings. So in this case, I give it a bunch of data, and it spits me out one of these kind of really nice looking strings. If you try and build anything more than about 3 data points, that becomes hard yourself. You don't want to be doing that. The line can also use the interpolators, which are built into D3, and the interpolators take care of interpolation, and interpolation in this kind of very many forms that are supported. You've also got data and time formatting. As I say, it's got everything in it. So you can format, and you can pass, and you can seal. You can imagine that really, really useful if you're trying to do anything with like date time axes, that kind of stuff. D3 doesn't really have any external dependencies. So that was pretty dry and dull. So here's some examples. So first off, here's a dry, dull standard. Oh dear. This is what I forgot to ask. Do we have internet?
Yes.
I knew there was something.
2 minutes.
Sure. Alright. Okay, we'll come back to the example. So let's pretend you've seen some really amazing examples, and now you're really keen. You really want to build some with D3. So the first thing you want to do is learn about data join. Hey. There we go. Thank you. There we go. That's really boring time series chart, but it is a chart. D3 can do charts. Let's go on from that. You can also do kind of more advanced stuff. So this is a bit of collision detection. It's got a bit of physics built into it. It's fun to play with. And kind of, I suppose, demonstrates that you don't have to build charts with it. What else has it got? Oh yeah, it's also got this. I don't know what that's about. So yeah, you can do lots of really useful stuff with D3. So it's a DOM abstraction. It has layout algorithms separating the algorithmic complexity out. It's got SVG helpers. It's got mis, and it's got data binding, which hopefully leads on to data join. So data join is the D3 concept of data binding. It's a bit weird. I think if anyone's played with D3, they'll probably admit it's a bit weird. It's not what you maybe logically think of as data binding. And also this contains spoilers. So this all takes place on board the USS Missouri. Now, on board the USS Missouri, they want a crew roster. So we've got the HTML we're going to use for it. Everyone knows HTML. It's blank, but notice there are 3 list items. We've also got the data. So on board, abbreviated list is Captain Adams, Commander Krill, and Chief Petty Officer Ryback. So before jumping into how to do it, let's quickly go over. This is running inside a render loop. It's not actually running at all, but if it were to be running, you can, like, hypothetically, it's inside a render loop. It's constantly being evaluated. It wouldn't matter when you ran the render function, is the point. So it would look something like this. Now, first off, to do the data join, we need the DOM nodes that we're going to join to. So first of all, select the list, and then we select the list items. Easy. Then we actually kind of want to perform the join. So the join is taking the data and taking the DOM nodes and merging them together. So you do that with the data. So far so good. So what we expect to happen is it will take the first DOM node, it will take the first data item, combine them, the second DOM node, second data item, combine them, third DOM node, third data item, combine them. But there's no point in doing that if we don't kind of act on it or do something. So let's set the text to be the name and the rank of the person, crew member. And as you'd expect, there we go, all done, data bound. Now, binding the data once is pretty dull and boring. So let's add someone. So the next person to join the USS Missouri, he came on, so I'll add him, add data item to the data. I'm bluffing because I can't remember his name. He's a civilian, he's called Stranax, and he's going to join the rest of the crew members. So we run that code again, but there's been no change. We've still got that same list. It's kind of that wasn't what we expected. We did exactly the same thing. We gave it more data. We expected something to pop out. But if you remember how it works, it was taking a DOM node, it was taking a data item, it's combining them, DOM node, data item, DOM node, data item. Now it's got an extra data item, but it doesn't have an associated DOM node. So, like, what's it going to do? You need to help it out. You need to tell it what to do. So you do that using the enter selection. So the enter selection is very simple. If we don't have a DOM node, and we need a DOM node, add a DOM node. So in this case, add an LI. Now if we run it, there we go. We've got a change and threat change. We've got all 4 members on board. It's all good. Now, for anyone who's seen the film, they know what comes next. Unfortunately, Captain, can't remember his name, coughs it, so he's out of there. So yeah, there's now 3. So let's rerun the data join. Again, it's all running in a render loop. Don't have to. Blah, blah, blah. So we've got change. It has changed, but that wasn't really the change we were looking for. We expected that last node to disappear. So again, going back to what it's doing, we've got now 4 DOM nodes, and we've got 3 data items. So it's taken the first DOM node, first data item combined, second, third. Then it's got to the 4th DOM node, and there isn't a data item. So again, it needs to be told what to do. So in this case, we do it with the exit selection. You probably guessed that. And pretty much you do what you always do with the exit selection, just remove the DOM node. You don't need that DOM node anymore, let's get rid of it. So there we go, we've got another change, and that's the change we were looking for. So those 3, the kind of the update selection, the enter selection, and the exit selection are the core components of doing a data join, and a data join in D3 is data binding. So spoilers, oh yeah, then the rest of them cough it, and yeah, he wins and battle them. Yeah, data join. What's interesting is that was all running in a render loop. So no matter how many times we ran that render loop, it didn't matter. The output was always stable unless we changed the input data or we changed the code. That's really interesting. That's a feature that, despite D3 being really quite old, that's something that we're only now starting to see, or very recently starting to see with things like React, where we've got virtual DOM and DOM diffing, is that kind of just throw the representation at the DOM and let something else deal with kind of working out whether we need to manipulate the DOM or not. So back then it was good because it meant performance. Less interaction means kind of better performance. But yeah, D3 is ahead of its time. So that was talking. Let's try the same thing, but I'm going to type it out. So we're starting with a blank canvas. It's a blank canvas. We've got some boilerplate, and we have some data. We have it exposed globally. Oh, this is all in a function. That will become important later. We've got a container we're going to render into. Oops, we've got a width, a height, some utility stuff. We're inside an animation loop, so we're rendering all the time. So let's find out if it really is an input. So let's do the data join. So container, select all data. Oops, data. Shouldn't have had that extra bit. So now, so we've done the data join, but now we want to do something with the data joins. Let's skip down here for reasons that will become obvious later. So let's tackle enter and exit first because they're easy. So enter, append, li, update selection, exit, oops, remove. There we go. So that's handled adding nodes and removing nodes, but we haven't actually done anything with it. We haven't like bound any data to it. We've just made sure that there will always be the right number of DOM nodes for the right number of data items. So now let's do something. We also definitely don't want LIs. Let's do it with rect. So we're going to set 4 properties on a rect. So it's an SVG rect element. So if we want to create a bar chart, then we're going to set it up as being an x coordinate, a y coordinate, a width and a height. Let's take them in order of easiness. So the easiest one is the x. So x is always going to be 0. We want to grow at the right hand side of the screen. So x 0. The next one is going to be the height of the bar. That's easy because I've already calculated it up here. So height, bar height. Then let's take the y coordinate, sorry, the width. So the width of the bar is going to be dependent on the data. So width. And we're going to run that through an X scale because that provides that translation between data and pixel values. So X scale, oops, I need to run this in a function. In D3, the data bound to an item is passed as a parameter. So do that. I've done too much ES6. There we go. And let's make an X scale. So do it quickly, D3 scale. Yeah. Domain goes from 0. There are automatic ways of doing this, but let's cheat. So let's say 30. And the range, so the pixel range is going to be from 0 to width. Cool. So that's set up our X scale. And then our Y position is going to be dependent on which index it's at. So the top one should be a 0, the next one should be bar height down, bar height down, bar height down. We can do that pretty easily. So function, the second argument you get passed is the index. So let's use that this time. Domain, so this time it's 0 to the number of data items there are. And we've got the range, and the pixel range is then again 0 to height. Okay, so that's set it up. Which way do we go? Nope, that's died. Live coding. Alright, dig into it.
I think its update should be update selection.
Totally should. Good spot. Okay. So that's really dull, quite boring looking, but accurate bar chart. Now to prove that it's running in the render loop, let's set a data item. Someone call out an index between 0 and 5. 3, I'll do. Someone call out a value. Any number.
42.
42, good work. There we go. It's live, running render loop. So it's that idempotent transformation. The other thing is the fill color. Let's make business like it. So d3 dot scale dot category 10, 10, 10. Let's fit fill color. Magic. So that was an example of creating a data join kind of from scratch. As you probably saw there, that kind of starts looking quite procedural, and you can imagine the more that you put in there, the longer that file's going to get. And that's kind of the traditional problem with D3 code. The proposed solution to that is to create components. Components are just functions. So again, going back to that tortured under siege reference, these are quotes from Katie Ryback, and also a component to add dramatic effect, so make the font weight bold. The problem is with just using functions, you end up with that doesn't look very D3. D3 has that fluent syntax. You want a way of kind of continuing that fluent syntax. So how do you do that? Well, you use call instead. So all that's changed is the way we've invoked it at the bottom, and everything else is exactly the same. But we can take it a stage further. So these are quite clearly kind of one-shot components. They're not configurable, they're not really reusable. So if we want to make them reusable, first of all we need to create instances of them. So we create instances by wrapping it in a factory. So factory is just a function which produces the instance. Then we want to add the kind of configuration in. So in this case, we configure the quote for Casey Ryback to say. So we've got a closure captured quote. We've got exactly the same code in the middle, but it makes use of the closure captured quote. And then we've kind of got this boilerplate, which you see all over D3, which is just a get setter which maintains the nice flow of the code. And then, yeah, we return it from the factory. In this example, of how you'd use it. So, yeah, as in JavaScript, components just a convention-based unit of use. What I quite like about D3 is it doesn't introduce any new syntax for creating components. It's just JavaScript. So quickly, we're going to do the most boring demo you could possibly do. We're going to make that chart, which is the one we made before, look exactly the same, but this time we're going to make it with components. So we've got the boilerplate at the top. You can see that's what I just introduced you guys to. And then at the bottom we've got what we wrote before, or a pretty printed version of it. So first of all, let's just grab this code. That code. So we've got the bit like the business, the data join, indentation. I'm going to pull this one out because bar height relies on height, which we don't have defined. You'll also notice we don't have X scale and Y scale here. Let's dump this back in here. As I just introduced, kind of configuring instances, let's configure an instance. So in D3, you would create instance variables, so X scale equals D3. You always kind of initialize them so that the components can be used without setting them. So you're kind of making them optional, or you're giving them default values. The simplest scales are identity scale. And the other one's bar height. And I've done a typo. Bar height equals, let's give it 1. So that's all good. They'll all just continue to use those values. All we need to do down here is, ooh, no. We don't have any accesses for those. I'm going to take those out. They're here. invoked by the indentation. And we just create the instance and pipe it in. So var series equals var series, x scale is x scale, y scale is y scale, and bar height is bar height. We then need to invoke it. So we do, we've got a container here, so we do container, we bind the data to it, and then we just call with series. And if it's all worked, it's exactly the same. Thank you. Totally deserved. So, that's all you need to know about creating D3 components and stuff. Where did we pick up knowledge from doing it? Well, we've got a project called D3FC. So D3FC was our attempt to create the ultimate charting library, the best charting library, the charting library that was going to rule the world. That's really hard. Like, everyone's got different requirements for charting. There's never going to be one solution. So what we kind of settled on was, well, we'll just embrace D3. We had a quick look around other charting libraries built on D3, and they all kind of try and hide D3 and don't really follow its kind of principles of small and composable and simplicity. So why don't we instead just kind of try and provide people with like a curated and consistent set of examples? So we try to just write small snippets of code that would be useful for you if you were using them to build a chart. Because yeah, D3 doesn't actually give you a chart layout, which is a bit weird. This is our website. We have a website. We're very modern. You can build charts. See, the charts themselves are built of components. So Cartesian chart gives you Cartesian layout. But again, it looks very D3. We're embracing D3. You can mix and match it with D3 code. And you can do more exciting, exotic chart types. So that's D3FC. And D3FC was probably where I learned how to write D3 properly. This project is where I learned to write D3 poorly. So this was kind of an idea that I saw a guy who'd created a website, and it was just his own personal project, and every day he would produce a D3 animation. And so he basically time-boxed himself to producing one a day, and that artificial constraint meant he had, by the end of it, lots of really pretty little examples of D3 animations. And kind of by introducing that artificial constraint, I think that's where the kind of artistic side of it came from. So I thought, someone's bound to have done this in a tweet before. So let's Google around for tweet size D3 code golf. No one had. So I created one. You've got 113 characters of code, because whilst the tweet is at 140, the way I chose to implement it meant that you included a link in the tweet to the website. That link is helpfully shortened by Twitter to twice the length that it started as. And then you lose a character because it needs to be delimited by white space because of Twitter's parser. So that website turned into, it's not the most performant website. So collection of tweet size D3 creations. And I started it off with the thoroughly inspired hello world. You can move it. Oops, not new. Then people followed it up with stuff that made use of D3 features. Really cool. You had all sorts of stuff popping out. Yeah, like D3 doesn't really do 3D, but you got loads of really cool pseudo 3D stuff popping out. And I don't know, pick some random. Should have looked through these before. I suppose there's quite a few that are very similar to some of the stuff that we saw before. Animation. This is how to write a non-performant animation. So yeah, there's been quite a bit of interest. There's quite a few on there. It's worth taking a look through. Weirdly, it went. They're pretty. It went kind of viral in Japan, which meant that it ended up, or like something I created, ended up in the weirdest like taxonomy of stuff I think I've ever seen. So yeah, who knew chocolate mushrooms existed? So yeah, that's how you create D3 components, how to write D3 code, and yeah, how not to write D3 code.